Hello everyone, it's Jiaxin Liu from Fudan University. Today, I want to present our new paper called RetouchingFFHQ, a large-scale dataset for fine-grained face retouching detection. I'm the second author of the article, and the first author is Jiaxin Liu. This work focuses on retouching techniques that are very popular right now, especially on social media and short video platforms. Previous researchers have built some datasets on retouching faces and constructing networks for detection. However, the lack of large-scale and fine-grained face retouching datasets has been a major obstacle to progress in this field. In this table presented here, we compare these works. It can be seen that there are obvious flaws in both the number of images and the way they are processed, and some of the datasets only take Caucasian females into consideration. To solve these problems, we introduced RetouchingFFHQ, a large-scale and fine-grained face retouching dataset that contains over 500,000 conditionally retouched images. I will go into the details below. The existing datasets are limited in size, and demographic characteristics are not distributed properly. Consequently, these datasets may not be sufficient to train robust detection networks. Correspondingly, our RetouchingFFHQ contains over 500,000 images, covering different races and ages. Secondly, often seen binary labels may not be sufficient to capture the complexity of face retouching, which can range from innocuous cosmetic enhancement to malicious forgery. By including 4 typical types of face retouching operations and different retouching levels, we extend the binary face retouching detection into a fine-grained multi-retouching type and multi-retouching level estimation problem. Here, we have selected some examples to show before and after images of retouching. The labels are attached in the down right. The graph at the bottom right shows the UMAP visualization and statistical pie chart of our dataset. To construct RetouchingFFHQ, we manually check origin images in FFHQ and remove a noticeable portion of unconscionable images. There are 5 categories of images to be cleaned. They are blurred images, cosplay images, incomplete faces, images of infants, and fake faces. More than 10,000 images are cleaned. Next, we process the remaining images to collect the retouching versions. In summary, 3 APIs, 4 types, and 4 levels of retouching are used. We use the online commercial APIs of 3 famous AI companies, including Megvii, Alibaba, and Tencent. For these APIs, we choose the 4 types of commonly used retouching, including skin smoothing, face whitening, face lifting, and eye enlarging. As for the levels, we categorize it into 4 classes, namely off, slight, medium, and heavy. According to these choices, the images are annotated in the following form. Since users may use multiple retouching types at the same time, we split the cleaned original images into 4 non-overlapping subsets for different retouching operations. We perform different amounts of retouching operations for different original image subsets. For example, each original face image in the subset 2 is retouched into 6 retouched versions, by respectively applying two types of retouching. This table summarizes our dataset, which counts all subsets of the images and reports the average PSNR between original images and their retouched versions. Here shows more examples of retouched faces randomly drawn from all subsets. We investigate how humans make predictions without reference to the original faces by scrutinizing the retouched images. Besides geometric distortion or noise level artifacts left by retouching algorithms, we find that the other critical factor relies on the features that can be learned from multiple granularities. Inspired by this, we propose a multi-granularity attention model, MAM, as a plugin for CNN backbones for enhanced cross-scale representation learning. The hierarchical features from the CNN backbones are clustered by the proposed adaptive token clustering method for spatial redundancy reduction. And then, the reduced tokens are concatenated with class tokens and positional embeddings. We employ a lightweight two-layered transformer encoder to analyze and compare multi-granularity information for detection. Besides, the multi-label classifier are added for every backbone to detect the specific type and level labels. Extensive experiments using different baselines, as well as our proposed method on RetouchingFFHQ, show distant performance on face retouching detection. It is shown in the table that we employ a number of representative CNN-based, transformer-based, and hybrid deep learning architectures as the baselines, namely VGGNet, ResNet, DenseNet, InceptionNet, ConNext, EfficientNet, CrossVIT, SwingT, Conformer, and QAdNet. In the experiments, we use all four subsets for each API set to train unified models for detecting images with different amounts of operations. Here, we show the in-API performance on the MACV set. We find that CNN architecture can perform generally better in our task compared to the transformer and hybrid counterparts. The overall performance of the networks with MAM plugin has significantly improved. Provided with models trained on the MACV set, we empirically find that they can be directly tested on the Alibaba set. While it requires some fine-tuning to be well-roundedly tested on the Tencent set, we find that the short fine-tuning is effective enough for models to adjust to the new protocols of the new platform. The results show that both the baseline networks and those with MAM have performance generalization, and networks with MAM still outperforms the baseline. The ablation studies are shown in the lower left corner. We can see in the existence of noisy data and excessive image details will mislead the models from learning faulty representations. In future works, we will collect and provide more retouching data from more online sources. Besides, provided with the fine-grained prediction result, we consider it also of great value to further estimate the possible original faces of the retouched images, offering references for users' subjective judgment. The presentation of this article is over. Thanks for listening.